All right, next video, doing more word problems. The slope of a certain road in West Virginia is measured with a slope of 5/13. What is the angle of elevation made by the road? So, got a road that's going basically uphill. The slope is 5/13, so that means up 5 over 13. So horizontal distance is 13. The angle of elevation is here. So the angle of elevation is going to be tangent of x equals 5 over 13. Second, or inverse tangent is 21 degrees. Okay. Next one. Bob and Tony have two separate tree stands on trees that are 65 feet apart. Bob's stand is 14 feet off the ground, and the angle of elevation from his stand to Tony's stand is 8 feet, or 8 degrees. How high off the ground is Tony's stand? All right, so we've got a stand here and a stand here. Okay, they're both up a certain distance. Okay, we know that they're 65 feet apart, so that's this. Bob's stand is 14 feet off the ground, so that's this. The angle of elevation from his stand to Tony's stand is 8 degrees. We can find that distance there. We can't find the whole thing. So how high is it off the ground? We're going to have to do something, right? We're going to have to add 14. Okay, but let's find the x value first. So basically how much taller, we're finding how much taller his stand is, and then we'll find out how tall it is off the ground. Okay, so tangent of 8 equals x over 65. So 65 times the tangent of 8. Oops, typed it in wrong. Gives me 9.1. So x equals 9. Okay, and that's how much. So basically, Tony's stand is 9 feet taller than Bob's stand. Bob's stand is 14 feet, so 14 plus 9 gives me 23 feet off the ground. All right, 27. The Goodyear blimp often gives aerial coverage of certain athletic events. To do this, regulations state that the blimp must maintain an altitude of at least 1,300 feet during the game. So there's a blimp. Let's draw an oval there. Altitude of 1,300 feet. At one point during a certain game, the blimp recorded its position to be 3,600 feet from the top of the stadium and could see the stadium at a 21-degree angle of depression. Okay, so stadium's over here. So it's 3,600 feet from that position. All right, could see the stadium at a 21-degree angle of depression. So that's going to be tough to put in there. That 21 degrees is right there. If the top of the stadium is 90 feet off the ground, so this is 90 feet. Is the blimp within regulations? So 1,300 is not what the blimp is at. We don't know that. Okay. What we can find, though, is how high the blimp is by adding 90 feet to x. Okay. So it's asking, is the blimp within regulations? Basically, is it 1,300 feet in the air or more? Okay. So we're going to use, this is 21. We use sine of 21 equals x over 3,600. So 3,600 times the sine of 21 is 1290.1. So yeah, 1290. But then you got to add the 90 feet that the stadium is off the ground. So plus 90 gives me 1,380. So this blimp is 1,380 off the ground. So yes, it is within regulations. Okay. Yeah, last one in this video. A recent storm, oops, has weakened a wall in Ted's house. To give it support, he wants to place 10-foot support beams against the weak wall. So there's a weak wall here. There's beams going to be laying against it. Okay? To do so effectively, the angle of elevation formed by the beams from the ground to the wall must be between 40 and 50 degrees. If Ted places the beams 4 feet from the house, so 4 feet from the house, the beams are 10 feet long, will he be providing the wall with enough support? So we're looking at what's the angle of elevation. It's got to be between 40 and 50 degrees. So we're using the cosine of x equals 4 over 10. So the inverse cosine of 4 over 10, 66.4. So just 66 degrees. No, he is not. All right, it's too steep of an angle. It's not going to provide enough support. Okay, what are the minimum and maximum distances from the base of the house Ted can place the beams and still provide enough support? So basically, we want to put in there basically this picture, except instead of knowing that it's 4 feet from the house, we don't know, and we're going to put 40 in there for the, actually it's going to be the maximum, and 50 in there for the minimum. So the beams are still 10 feet, so we're looking at cosine of 40 equals x over 10. So 10 cosine 40, 7.7. And then 50. We want to do 50 as well. So 10 cosine 50, 6.4. So it's got to be between 6.4 and 7.7 feet from the base of the house. Okay. That's going to be trickier than anything you're going to have to do on the test, but it's a good way to look at how you can use trig in other situations. Okay. That's it. Move on to vectors on the last video.